In this video we will have a look at phenomena observation by wandering across data collected by the Huron system. The system stores its analysis data in a database. After having collected all the required details about phonology, syntax and metrics, we can start looking at higher-order phenomena, like hiatus, elision, word-end distribution, metrical laws, accentual profiles, etc. Such observations are generated by modular software components, named observers. Each observer is specialized in a phenomenon, whether it's a well-known one or just a work hypothesis. In turn, observations are stored in the database, too. In general, any observation is modeled as a set of features, often ordered in some meaningful hierarchy. Each feature can have an open set of values, like a frequency, or a closed one, when it's categorical. For instance, consider hiatus. Whenever we find the contact of two vowels belonging to different syllables, we have one. Anyway, of course there are a lot more nuances to be observed in this phenomenon. One of the most relevant features of hiatus for metrics is its capability of shortening the preceding long vowel. When this happens, we have prosodical hiatus. This is often a useful metrical device, so it's relatively common. Then, of course, we have to distinguish between hiatus between words, the so-called external hiatus, and that inside a word, internal hiatus. A further complication here is that cases of external hiatus are not all equal. Some of them happen to be located at a true word boundary, while others are between two rhythmically coalescing words, like an article followed by a name. In the latter case we have a false word end, which is purely graphical. Further, a lot of factors concur in determining the strength of a word end besides the presence of a clitic word. For instance, punctuation is modern, but it reflects an articulation of syntax and meaning, hinting at a stronger potential pause, where hiatus is often easier to find. Inversely, elision often hints at a stronger connection between words, such as that required to trigger this phonosyntactic change. So, when observing hiatus, we don't just want to count its frequency. We want to provide more details, whether it is prosodical or not, whether it's internal or external, and whether the word end is true or false, and the presence of punctuation or elision. Finally, hiatus may occur in many positions in verse. So, in addition to all these features, we also register its position. So, we have a composable architecture, where at any time we can add new modules for observing new types of phenomena on top of the same base data. This is also essential to clearly separate the base empirical evidence from its interpretation. We are thus free to design and plug our observers to enrich our database with highly specialized data. For instance, here you can see a list of poetic observers for any language, Greek and Latin, or specific to Greek. Some of these, like those related to tones, are based on working hypotheses, backed by scholarly studies in the field of Greek accent and rhythm. Let us now see some observations. Data are shown from a database of Greek epic verse from Homer to Nonnos, covering about 200 documents, 500,000 words, more than 1 million syllables, 3 million segments, and 35 millions of subphonetic traits. This is the basis for observations, which here have been conducted on 19 phenomena, for a total of 6.5 million observations. So, these are really big metrical data at our disposal. Let us now see how the Observations UI allow us navigating this ocean of data. Say we want to look at hiatus. We thus move to the Observations list and pick a session. Every analysis is performed inside a session, which provides all the parameters for it. This also allows for multiple analyses of the same text. In our case, we just have a single session, so we easily find it. Let's now pick hiatus. Once we have picked it, we also get some information about the phenomenon. Here we can see its identifier in the database, together with its name. Also, the word positional tells us that this phenomenon is located at a specific position in the verse. A short description gives us a summary about the essential aspects of the model. This is what we have already illustrated about it. Finally, we have the standard language codes of the languages covered by this observer, Ancient Greek and Latin. Now, we can see more details about the features, which are 6. This is the core of the model, and is especially fit for data science. Our phenomenon here has 6 dimensions, from prosodic to mute. Each phenomenon has its own dimension number and types, but all phenomena share this general model. Thus, we can describe phenomena of any complexity by adding as many dimensions as features to it. We've seen most of the features for this phenomenon, whether it's prosodic or not, whether it's external, because the vowels are in 2 different words, or not. In the former case, we distinguish between true and false word end. We then have punctuation strength, ranging from 0 to 4. Then there is elision, which can be either present or absent. And the same holds for a couple of other minor Boolean features of word end, like bridging and interposed mute. In this case, all the feature have closed, categorical values. These are represented by the colored symbols. These symbols get concatenated in a single string, which represents all the 6 features at once. So, enough theory, time to see some real text now. As you can see, filters allow us to specify features, document, corpus, unit number, location, and verse position, and we can combine all these together. Yet, without any additional filter, let's just ask for all the verses with hiatus. Of course, we'll get a lot of them. In fact, they are more than 166,000, as we can see at the bottom of the first page. Let us now look at the top of the page. This is from verse 2 of a poem by Nicander, whose title is Alexipharmaca. The phenomenon is highlighted in the text. As you can see, this is a case of internal hiatus at the first syllable of a 2-syllables word. That's an archaic Ionic form of genitive plural, later contracted in Attic. The ending is the same of a Latin word like rosarum. Now, we have landed on this verse starting from a very generic query. As usual, at any time we can always delve into maximum detail, up to subphonetic level. I can click on the first letter of the syllable and get more information about it. Among other details, you see that the internal hiatus is annotated. We can even look at the traits of this single phoneme, the plosive dental at word start. Here we find all the details about it. Among them there is hiatus. As shown here, it's an internal one. Now, back to our verse. let's look at the row just above it. Here all the features of the phenomenon are listed, with their value, from left to right. This is not a prosodical hiatus, and it's not in a word end. Consequently, it has no punctuation, elision, or other Boolean features. Finally, in the row just below features, the red symbol is the metrical citation related to the position of the phenomenon in the verse. Here it means the second syllable of the third dactylic foot. That's a lot of data for a single verse. Yet, we have these details for each single verse listed here. For instance, consider verse 8 from the same work. Let us scroll down a bit in the same page. Here we have an external hiatus on a monosyllabic word, chi, a high-frequency proclitic word, meaning, and. So, this is an external hiatus, as you can see from the features. And its word end is false, because there is no real word end after this proclitic word. Also, hiatus here shortens chi, so, it's a prosodic one. In fact, if we look at the details, we can see that the syllable affected by external hiatus here is said to be shortened by virtue of it. Also, we learn that the word is a proclitic and a conjunction. That's why we have no true word end after it. Now, let's look for a more specific phenomenon type. This time we want to see only cases of prosodical hiatus on true word ends. As you recall, features are composed of the symbols for each feature's value. So, in the features box we just type the values corresponding to prosodical, P letter, and to true word end, T letter, followed by a % character, representing a wildcard which matches any tail. Also, we want to limit our results to the third foot of the hexameter only. So, our position filter will be equal to 3, followed by the usual wildcard. We then apply this new filter. Now we got only some 1,600 results. As expected, all the highlighted syllables are word final, before a true word end, and they are shortened by hiatus. For instance, look at verse 154 from a Hellenistic poem by Aratus. Here we have a prosodic hiatus at true word end. If we get into details, again the external prosodical hiatus is included in the comments. Also, notice that this is an enclitic word, which leans onto the previous word. This is the opposite of a proclitic word, like chi that we have just seen. This is the dative of the first-person pronoun, in its unaccented, unemphatic form. That's why the previous word has a secondary accent, which, by the way, confirms its enclitic nature, as remarked here. Now, if we highlight all the syllable with hiatus by adding a trait filter, we can see that this is not the only case in verse. There are 4 other cases, but they are all internal. So they were not included in our results, as we've asked for external hiatus only. Finally, let's change our filters again. This time we want all the cases of prosodical hiatus on true word end, in any position, but including a punctuation at least as strong as a full stop. So, let's remove the verse position filter first. Then, let's have a look at the information on this phenomenon. Under punctuation, you see that while P0 stands for none, other values represent stronger punctuations. P1 is for comma, so we don't want it. The same holds for P2, which is for colon or semicolon. What we want is P3, which is for full stop, and P4, which is for question or exclamation marks. Given this information, let's set our filter. This time we're using a regular expression, which is easier. We check the corresponding option and type a regular expression which matches strings beginning with P and T, followed by P and either 3 or 4. Now we are done, and we can apply our new filter to get all the prosodical hiatus on true word end with strong punctuation. Our results decrease to less than 200 cases. As expected, you can see that all the highlighted syllables are followed by a strong punctuation mark. Again, if we filter traits on the first result, we see that there are other cases of hiatus in the verse. These are just after our highlighted word. Yet, one is internal, and another one is external. Let's look at the external one. This is a proclitic word, so there is no true word end after it. Further, there is no punctuation, too. That's why it was excluded from the results. We could continue, but this should give you an idea. Once we have our observations, we can explore them in this interactive lab. This allows us jumping seamlessly between aggregated data, as selected by filters, and each single piece of text matching them up to the subphonetic level. So, we can constantly switch between a more distant or a closer reading approach, examining evidence about phenomena of our interest. As all the phenomena share the same model, the same environment can be used with any phenomenon. For instance, let's have a quick look of some other simple phenomena. To start with, word ends have a paramount importance in defining rhythm. Caesarean bridges depend on them, together with a lot of more detailed scholarly observations, known as metrical laws. For instance, Hermann's law tells us that in hexameter we rarely find word end after the so-called fourth trochee, that is, after the second syllable of a fourth dactylic foot. So, let's have a quick look at word ends in this position. We expect to find few instances, and most of them be false word ends. As we have seen, these word ends involve clitics, and are only graphical words, while rhythmically building a unit with their host. Let us pick the word end phenomenon. As we can see from the model, this observes the distribution of word ends in verse, with 6 features: true or false word end, punctuation strength, hiatus, elision, bridging, and interposed mute. Let's just look for any type of word end in this position. We get about 2,700 cases, on a total of more than 86,000. This means about 3%. Yet, if we look at them, we easily see that in most cases they include clitics. For instance, the first verse has chi, a proclitic, before the word end. This means that there's no real word end after it. Conversely, the second verse has fin, an enclitic, after the word end. This means that there's no real word end before it. So, these are not true violations to the law, because there is no real word end in this position in such cases. Let's refine our filter. This time we only want true word ends. So we enter our features filter, T, which stands for true. This really cuts down our results to a total of about 200. This means 0.3%, more than 10 times less than before. So, Hermann's law is really something relevant. That's why it was one of the first patterns to be found, more than 2 centuries ago. There would be much more to say here about this and other laws, especially in the bigger context of all these data. You can find a sample of such analyses on them on one of my papers. Anyway, on passage, this shows the importance of taking into account clitics when analyzing rhythm. Of course, the more strength we add to a word end, the less we expect it to be found in such position. For instance, consider hiatus. This is another candidate for a strong pause indication, so we would expect it to be very rare in this position. Let's refine our filter again. This time, we add H1, which means presence of hiatus. This leads us to a striking total of 8 cases in the whole corpus, consisting of more than 86,000 verses. Among them, 2 are even showing the same pattern for the second portion of the verse, with the same proper word for harpies. And that's what we expected, together with Hermann. You should now start realizing the potential of such an interactive linguistic and rhythmic corpus of texts. As we have seen, we can combine data at any level of detail, from all our analysis layers, ranging from phonology to syntax and metrics. This is essential when dealing with complex systems, where a lot of factors are at interplay. Let's see another quick example. This time we will look at elision and see its interaction with clitics. Elision depends on word ends, which in turn are constrained by the distribution of dactylic or spondaic feet. Also, elision is strictly related to the lexicality level of a word. In turn, this depends on a lot of factors, like accent, length, part of speech, semantics, and textual frequency. Also, elision is more frequent at higher speech rates, and in literature, this also depends on genre. The whole picture then changes according to genres and time periods. So, there are a lot of factors here, but it's right the massive amount of collected details which can help us analyzing our texts. Let's look at the elision model by picking it from the phenomena list. Our features include whether it's elision or protelision, the number of syllables in the affected word, and its lexicality. We start picking the elision. This means entering E for elision in our filter. Of course, we have a lot of results. Often, short enclitic particles like day or gay are perfect candidates for elision. They also provide an excellent device for lengthening syllables or protecting them from hiatus. This can also be connected with covering lost archaic sounds, like Vav, whose memory still left traces in this highly formular epic. So, maybe we want to look at these minimal particles only. All what we have to do is refining our filter. We add S0, meaning that we want only words resulting in no syllables once elided. As expected, we find a lot of such particles here. These are a lot, so let's refine our filter by picking only the first book of the Iliad. That's a perfect candidate for quickly looking at cases of such particles covering our ancient sound. In fact, we can find many of them even in our first page. In the first verse, the word for valiant, right after the highlighted particle, originally had this lost consonant at its beginning. That's probably the same root as in Latin vis, meaning strength. On passage, on the second verse this highlighted word might also be read without an elision, thus depriving the following word, etelaito, of its initial e, which is an augment. This prefix is systematically added in later Greek to mark historical tenses, but in Homer it's still optional. So, we could even read the full particle day, moving the space by one character forward. Apart from this, again at verse 19 we find day before the word for towards home. This originally started with our lost sound, to. This is the same root as Latin vicus. Finally, at line 48 we have another example, with ian, meaning arrow. This is the same root as the English word virus. Of course, should we really be interested in this lost sound, we'd have better use a specialized observer. This is just a way of showing how we can leverage the high granularity of our elisions features. We had a look at this minuscule particles. Let's now do the inverse and see how elision affects much longer, non-clitic words. We expect them to be much rarer. So, in our filter we now enter E and S4, meaning that we want elided words with 4 syllables. If we look at our results, we see these long words highlighted. Yet, these cases are rare. There are about 400 such words in more than 86,000 verses. And again, that's what we expected. Finally, let's see a corner case where the clinic status of a word is affected by its syntactic context, which in turn has effects on metrics. In Greek we have the so-called continuative words. We have seen that proclitic words attach themselves to the next word, and inversely, enclitic words attach themselves to the previous word. In some cases, the word after a proclitic happens to be an enclitic or the like. In this case, its mass is not enough to arrest the forward movement of the preceding proclitic. The result is that we have no true word end even after it. These continuative words are perfect candidates for an elision, which strengthens their forward connection. We can thus see only such words by changing our filter. As expected, many of them are just the minimal enclitics we looked at before. For instance, in the first verse we find the proclitic first word, hose, followed by the elided form of day. This works here as a continuative, so that there is no true word end after it. Again, the details are available by clicking on it. We can see that this is marked as an elided, enclitic particle, working as continuative. In fact, its preceding word is marked as a proclitic. Even these few minutes should be enough to let you feel the potential of such an approach. Having amassed a lot of detailed data about phonology, syntax, and metrics of thousands of verses, stretched across many centuries, from the dawn of Greek literature to late antiquity, we can leverage this sort of true laboratory to observe any phenomena, whatever their complexity or reality. So, here we have just scratched the surface, and many other reflections on data are possible by exporting them and using data science tools. Yet, that's a tale for another time, a sequel waiting to unfold in a different video. Thank you for watching.